Good day, students. Welcome to our video session. The topic we are going to look at today is indices. So it's a very, very important mathematical concept. Okay? Now, the learning objectives for today's lesson is to be able to use index laws to multiply and divide terms with powers. That is the learning objective for this lesson. Now, indices is the mathematical term for power. Okay? Indices is the plural term for index. In actual fact, the plural term for indices is what? Index. Though at times you can even call it power as well. In the United States, they use the word exponent to represent what? Indices. Okay? Now look at what we have here. This is 5, this is 4. This 5 is always called the base. This is the base number. Okay? While this 4 is the index or exponent or the power. Exactly. So you observe that this number appears bigger than this. The base is always written, okay, it's always bigger than the what? The power or the exponent or the index. Okay? Now, let's continue now. What does 4 raised to the power 2 actually mean? Okay, 4 raised to the power 2 actually mean 4 times 4. That means the base was repeated twice. Okay, this is the base, this is the power or index or exponent. So 4 raised to the power 2 simply implies you repeated the base, which is 4, how many times? 2 times. Okay, that means this 2 is the number of times you repeated the what? The base. And this index implies repeated multiplication. So when you see something like this, 4 raised to the power 2, that means it represents what? Repeated multiplication. If it were to be 5 raised to the power 3, that means 5 times 5 times 5. The index or the exponent shows number of times it was what? Repeated. Okay? If we decide to change these 2 to 5, so it's going to be 4 times 4 times 4 times 4 times 4 in 5 places. Okay? So this one is simply 4 times 4. And what is 4 times 4? 16. So 4 raised to the power 2 is 4 times 4. And 4 times 4 is what? 16. Now, let's look at another one again. The exponent in this case is now 4 raised to the power 5. I remember I said that when you have something like this, it means repeated multiplication. Okay? And the way it was written, you have to be very careful when you are trying to write something like this. You don't write it as 45. Okay? So it has to be something like this. This is the base, then this is the what? The power. So this is 4 raised to the power what? 5. And you have to be very careful. There's a difference between 4 raised to the power 5 and what? 45. Okay? So this means 4 times 4 times 4 times 4 times 4. That is the repeated multiplication here. How many 4s do you have here? 1, 2, 3, 4, 5. Since we have 5 of these, that means the exponent or the power or the index will be what? 5. Okay? Now if you multiply 4 times 4 times 4 times 4 times 4, what I'm going to have is 1024. Okay, you're going to have 1024. Okay, now let's go to the next slide. Now look at this. How can we write 5 times 5 times 5 times 5? Okay, now the base is common. That is what? 5. You are going to write 5 as a common base, right? Now, how many times do you have 5 here? 5 appears 4 times. So that will give you 5 raised to the power of 4. Now, this is now written in index form. Okay? So this is written in what? Index form. Now, you have to be very careful about this. If you have, let's say, 5 times 4, I'm trying to differentiate between repeated addition and repeated what? Multiplication. If you have 5 times 4, 5 times 4 can be written as 5 plus 5 plus 5 plus 5. Okay? So when you have something like this, this is what? Repeated. This is repeated addition. This is repeated addition. Okay? Okay? But if you have 5 raised to the power 4, okay, that will give you 5 times 5 times 5 times 5. So when you have something like this, this is what? Repeated multiplication. Repeated multiplication. So that's just the big difference between the two, okay? So this 5 raised to the power 4 is repeated multiplication, 5 times 5 times 5 times 5 in 4 places, okay? But 5 times 4 is repeated addition, meaning 5 plus 5 plus 5 plus 5. So this is how to write it in index form. If you have 5 times 5 times 5 times 5, if you want to write it in index form, it is 5 raised to the power of what? 4. So this is the base again. This is the power, the index, or the exponent. So let's go to the next page. Now look at this. Write the following in index form. You try as much as possible to pause the video and try to attempt this. Okay? 3 times 3 times 3, 8 times 8 times 8 times 8, and so on and so forth. Then you have this again. You observe that they will all have the same base. Okay? Just try it. Okay? Now the challenge is this. Do you think it matters whether the base number is always the same? Now, can you put a number into index form by multiplying different numbers together? Try it out. Can you see? Can you put a number into index form by multiplying different numbers together? Try it out. Now, let's go to the next page. Okay, you observe that this will be the solution to the previous slide. Okay, so you have this as a solution. Now, do you think it matters whether the base number is always the same? Can you put a number in index form by multiplying different numbers together? Try it out. Okay, so now let's go to the next page. Now let's look at the first example. What we have here is 8 raised to the power of 3 times 8 raised to the power of 4. If you decide to write this in the expanded form, 8 raised to the power of 3 implies multiplication of 8 how many times? 3 times. So if you write this in the expanded form, this will give you 8 times 8 times 8. So you have 3 of these. Why? Because the exponent is 3. Okay? Now let's look at this one. This is 8 raised to the power of 4. That means 8 appears 4 times. We multiply it together 4 times. So this will be 8 times 8 times 8 times 8. You write it in the word expanded form. Now, what do you observe here? How many 8 do we have here? 1, 2, 3, 4, 5, 6, 7. Okay? You have 7 of these. So that means the final answer is going to be 8 raised to the power of 7 in index form. Okay? So if you write all these in index form, since we have 7 8s, 1, 2, 3, 4, 5, 6, 7, the final answer is going to be 8 raised to the power of 7. So this 8 is like common to all the numbers, okay? That's the 8 there. Then the 7, 1, 2, 3, 4, 5, 6, 7. That means you have 7 8s here. So the 7 will now be our exponent. So the final answer is 8 raised to the power of what? 7. Now, let's look at example 2. Here, in example 2, we're told to simplify 5 raised to the power of 2 times 5 raised to the power 4. Now, 5 raised to the power of 2 times 5 raised to the power 4. Now, what is 5 raised to the power of 2? We write it in the expanded form. That will be 5 times 5. Okay? Now, what about 5 raised to the power of 4? You write this in the expanded form. That will give you 5 times 5 times 5 times 5. Okay? Now, how many 5s do you have here? 1, 2, 3, 4, 5, 6. That means the exponent is going to be 6. So, since 5 is common here, the final answer in index form will give us 5 raised to the power of what? 6. So, if you want to write this in index form, the final answer is going to be 5 raised to the power 6. Now, this is very important here. Very important. So you need to know that this only works for numbers with the same base. Okay? This only works for numbers with the same what? Base. So that is a very important point. Okay? Because if this were to be 5 and this is 8, there is no way this would be possible. Okay? It only works if you have the same base. As you have 5, 5 here, 8, 8 here. Okay? So now let's move to the next page. Now, what do you observe? From the previous slide, 8 raised to the power of 3 multiplied by 8 raised to the power of 4 give us 8 raised to the power 7. For the second example, 5 raised to the power of 2 times 5 raised to the power of 4 give us 5 raised to the power 6. Now, there's a question here. Is there a quick way, based on our previous working, is there a quick way from the observation? Okay? Now, add the powers. So, can you see? Add the powers. So, that means if you are given something like this, they have a common base, so you are going to pick 8. Then you now add the exponents. You add the power. 3 plus 4 will give you 7. Here you have a common base. Remember, you can only do this if they have the same what? Base. So you are going to pick 5. Since 5 is common to both, you are going to write 5 here. Then you now add the power. 2 plus 4 will give you 6. So that is the fastest way to solve that. So remember, add the powers, provided the operation here is what? Multiplication. And there is a common mistake being made by some students. Some would write like this now. Some students will write 8 after writing 8. So they would think they have to multiply 3 by 4 again, right? To give 8 raised to the power 12. This is totally wrong, okay? The best thing for you to do is you pick one of the base, right? Then you now add the power, okay? Which is 3 plus 4, so that you have 8 raised to the power of 7, okay? The idea of multiplying the exponent is totally what? Wrong, okay? So this is the answer. So remember, always add the powers anytime the operation here is what? Multiplication. You add the powers. And remember, for that to occur, or for that to be possible, that means you must have the same what? Base. Now, look at this now. Am I correct? We have 5 raised to the power 6 times 6 raised to the power 5. There is no way you can combine this together. Why? Because the base here is 5 and the base here is what? 6. Okay? It will only work if you have the same base. So this is totally wrong. This is what? Wrong. Okay? You can't get 30 raised to the power 11. Now look at this one. Of course, you have the same base, 5, 5. Now, look at this exponent, 30. So that means this one was doing by multiplying 6 by 5. that violates the rule. Okay, so this is totally wrong. You are not expected to what? To multiply the exponent. So this is also what? Wrong. Okay, now let's try to look at the third illustration here. We have 5 raised to the power of 6 times 5 raised to the power of 5 equals 5 raised to the power 11. Now you observe that you have the same base, 5, 5. So you're going to write 5. Can you see that? Now the exponent must be what? Added together. So this is going to be 6 plus 5. What is 6 plus 5? 6 plus 5 will give you 11. So out of these three, this is what? Correct. Okay, so the first two is out of it. Okay, so that is the answer. So now let's go to next page. So now let's look at this now. We've been able to look at operation involving multiplication. Now let's look at another operation, which is division. So let's look at how we divide indices. Now for the first example here, we have simplify 2 raised to the power of 5 divided by 2 raised to the power of 2. Okay, now the first thing we do is you write this out in expanded form, which will give us 2 times 2 times 2 times 2 times 2. Because the exponent here is 5, so you now repeat this 5 times. You multiply by itself 5 times. Okay? 2 times 2 times 2 times 2 times 2. Now divide by this division symbol, 2 raised to the power of 2. That means you are going to rewrite this. You multiply by itself 2 times. Okay, the power will tell you the number of times you multiply the base by itself. So this is going to be 2 times 2. Now if you now look at this, we have common factors at the numerator and what? Denominator. Okay, so they will both cancel out. So 2 goes here 1, 2 goes here 1, right? 2 goes here 1, 2 goes here 1. Can you see that? So we now have 2 times 2 times 2. Common base, you write 2. How many times do you have 2? 3 times. So the exponent is going to be 3. So the final answer here is 2 raised to the power of what? 3. So that's the solution to this problem here. Okay, now let's look at example 2. Simplify 3 raised to the power of 5 divided by 3 raised to the power of 2. Okay, now decide to write this in the expanded form. 3 raised to the power of 5, that means you multiply 3 by itself 5 times. Okay, repeated multiplication. So this is going to give us 3 times 3 times 3 times 3 times 3. The division sign, you write something like this, write it out. Then 3 raised to the power of 2, 3 times 3. Okay, now what else? We're going to cut out each of these. 3 goes here 1 because they have common factors. 3 here 1 as well. 3 goes here 1. 3 goes here 1. Okay, so we are left with how many 3s? 1, 2, 3. So we'll start by writing the base because we have equal numbers here. The base is going to be 3. Now, how many 3s do we have here? 1, 2, 3. The exponent is going to be what? 3. So the final answer here is going to be 3 raised to the power of what? 3. That is the final answer here. Okay? Now, remember again, this only works for numbers with the same base. Okay? Now, let's go to the next page. Now, if we decide to write out what we have in the previous slide, remember this was the question. We got this. For the second one, we got this. Now, is there a quick way from what we observe here? Of course, there is. If we compare the two solutions we have, what do you observe? You subtract the powers. Okay? You simply subtract the powers, because if you look at this, 2 raised to the power of 5 divided by 2 raised to the power of 2. You have the same base, 2, 2, then you write 2. Now, this operation, the division sign, will turn to subtraction. So this is going to be 5 minus 2. 5 minus 2 will give us 3. So the final answer here is 2 raised to the power of what? 3. Now, let's look at this one again. Since we have the same base, 3, 3, you write 3. Now, subtract the power. 5, this will turn to minus. 5 minus 2 will give you what? 3. That is 2 raised to the power of 5 divided by 2 raised to the power of 2 will be equal to, you have the same base, you write 2, then this will turn to minus, you subtract the power, 5 minus 2, so that the final answer is 2 raised to the power of what? 3. So that's the solution to this problem. So for this, you have 2 raised to the power of 5 divided by 3 raised to the power of 2. That's what to give us. Since we have the same base, you pick one of the base, that is 3. Then you simply subtract the power. So that will give you 5 minus 2. Okay, so you write this 3. Then 5 minus 2 will give us 3. So the final answer here is 3 raised to the power 3. So remember, when you have division as the operation, you have to subtract the powers. If the operation was multiplication, you add the powers. That's just the inverse. So now let's move to the next slide. Now let's look at this. Now, am I correct? Okay, if you try to solve the first one, 2 raised to the power 12 divided by 2 raised to the power 3. We have the same base, we write it out, that's 2. Now, what happens to the exponent? Because this is subtraction, this is division, so we have to subtract. That will be 12 minus 3. Okay, so that will give us 2 raised to the power 12 minus 3 will give you 9. So the correct answer ought to be 2 raised to the power of 9. But here you have 2 raised to the power 4. So this is wrong. Okay? Now, 2 raised to the power of 12 divided by this, we have 2 raised to the power 9. Yes. So this is correct. Okay? Based on our explanation here. Now, you can't combine these together. Why? Because you have 24 here and 2 here. You can combine these together, The rule states that you must have the same base before you can combine indices. Okay, so this is totally wrong. So this will not work. Is that clear? So that is the solution here. Now, the summary. To summarize in this section, we have found these laws of indices. Okay, here the multiplication law. For instance, we have x raised to the power of a multiplied by x raised to the power of b. That will give us x raised to the power a plus b. That means this operation here, multiplication, will make us add the what? The powers. Okay, so it has to be x raised to the power a plus b. S will represent any given number. Now, the division law here, x raised to the power a divided by x raised to the power of b will give us x raised to the power a minus b, which is the inverse of multiplication here. So now, in this case now, since we have the same base and we decide to write x, the division here will now turn to subtraction. So this will give us x raised to the power a minus b. So this is the division law, while this is what? Multiplication law. Okay, so if you have any problem involving multiplication or division, you simply apply these laws. We call them laws of indices. We have other laws too, but because we are just going to make reference to just only these two in the course of this class, so we are going to base our questions on just the multiplication law and division law alone. In our next class, we're going to look at other laws. Okay, so now let's go to the next page. Now we have some other examples here. We have 4c raised to the power 3 times 7c raised to the power 2. Okay, so now we are told to simplify all these expressions. So now to start with, from the first question, you write 4c raised to the power 3 multiplied by 7c raised to the power 2. Okay, now to solve this, you simply separate the numbers from the letters. Okay, so you bring out 4, right? You bring out 7. 4 times 7, can you see that? Multiply by c cubed, or c raised to the power 3 times c squared, c raised to the power 2. So you try to separate the numbers from the letters. So now, what is 4 times 7? 4 times 7 will give us 28, right? Now, to apply our rule, we have the same base, so you pick one of the base, that's c. Then you now simply add the exponent. Why? Because this operation here is multiplication. So you are expected to add the what? The exponent. So this is going to give us 3 plus 2. Okay? So what's our final answer? Our final answer will give us 28 c raised to the power of what? 5. Okay? That's the solution to this problem. Our final answer is 28 c raised to the power of what? 5. So let's look at the second example. Now for the second example, we have 12a raised to the power 7 divided by 3a raised to the power 2. Right? The first thing is you separate the numbers from the letters. So this is 12 divided by 3. 12 divided by 3. Can you see that? Then this is going to be a raised to the power 7 divided by a raised to the power 2. A raised to the power 7 divided by a raised to the power of what? 2. Okay? And simply put this in brackets. Right? Now 12 divided by 3 will give us 4. Now we have the same base. We pick one of the base. The operation here is division, and the law states for the division law you have to what? Subtract the exponent. So this will give us 7 minus 2. So the final answer here will give us, this is 4 a raised to the power, what is 7 minus 2? That will give you 5. Final answer here is 4a raised to the power of 5. Now let's look at question 3. In question 3 we have 2c raised to the power minus 7 multiplied by 3c raised to the power 3 times 7c raised to the power minus 2. You separate the numbers. That will be 2 times 3 times what? 7. When you separate the numbers, right? Then you bring out the indices. That will be multiplied by c raised to the power minus 7 times c raised to the power 3 times c raised to the power minus 2. Now, what is 2 times 3? 2 times 3 will give us 6. 6 times 7 will give us 42. So this will give us 42. Now, look at this. We have c here. Okay, they have a common base, so you pick one. So you now have minus 7. You add this will turn to plus what? 3. Then plus, this will turn to plus. minus 2, right? This will give you 42 series power. Minus 7 plus 3 will give you 3 minus 7 plus 3 will give us 3 minus 7, which is what? Minus 4. Okay? Right? Minus 7 plus 3 is same as saying 3 minus 7. That's minus 4. Now look at this now. Plus times minus. When you multiply a positive sign with a minus sign, you will not be happy, right? So these two signs will not be happy when you multiply them together. So this will now give you minus, right? Okay, so plus times minus will give you minus. Then you drop down 2, right? So this will now give us 42 series to power minus 4 minus 2 will give us minus 6. Okay? Minus 4 minus 2 will give us minus 6. So that is going to be the solution to this problem. 42c raised to power minus 6. Okay? Just try much as well to combine this together. You can see you can start with the positive sign. Where you have minus 7, you have plus 3. You start with this as 3 minus 7. You are taking away 7 from 3. So 3 minus 7 will give you minus 4. Then plus times minus. These two signs will not be happy to turn to minus, right? Then now drop down 2. So minus 1 minus 2 will give you minus 6. Then 42. So 42 series power minus 6 will be the solution to the problem. So now let's look at the next example. Example 4. Now here you have 24 a raised to power minus 3 times 3a raised to power minus 5. Just like we've done in the previous one, we try to separate the numbers from the letters. So this is 24 times 3. 24 times 3. Then now combine the indices. So this will be multiplied by a raised to power minus 3 times a raised to power minus 5. 24 times 3 will give us 72. Because 3 times 4 is 12. 3 times 4 is 12. You write 2, carry 1. 3 times 2 is 6. 6 plus 1 will give you 7. 24 times 3 will give you 72. Okay? Multiply by. You have the same base, so we can combine these indices, right? You have a here, a here. So that means you are going to write a. That's the first step. You must have the same base. Now you have minus 3. Write out minus 3. This operation here will turn to plus. Plus what? Then this is what? Minus 5. Minus 5. Okay? So this is going to be 72. A. This is minus 3. Now look at this. Plus multiplied by minus. Okay? These two signs will not be happy when you multiply them together. As long as they are different signs, it will always give you minus when you are multiplying them. So plus and minus will not be happy to turn to what? Minus. So we now drop down 5. Can you see that? So this is going to give us 72. A minus 3 minus 5 will give us minus 8. Minus 8. So the final answer is 72 a raised to power minus 8. Okay? Now let's look at more examples. Let's look at more examples. Let's look at more examples before we talk about the assignments. Now, for instance, if you have 100p raised to power minus 8 divided by 25p raised to power minus 7. So, how can we solve this? Now, this is 100 divided by 25. Remember, separate the numbers from the letters. So this is going to be 100 divided by 25. Now, what we have here is p raised to power 8. We have p raised to the power minus 8. Now divide by p raised to the power minus 7. So now let's reduce this. 5 here, 5. 5 and 10 is 2. In 0 will give you 0. 5 here, 1. 5 and 20 will give you 4. So all these in the bracket will give you what? 4. Now, what we have here is P and P, right? We pick one of the P. There is minus 8 here. You write minus 8. The division sign will turn to minus, right? This is going to be minus. Okay? We now combine it with minus 7. The division sign here will actually turn to minus. This is minus. Then you now have minus 7. Put this in bracket, minus 7. Okay? So now this will give us 4p. You write out minus 8. Now look at this. We are multiplying two signs that are the same. When you multiply two signs that are the same, either positive or negative, the two signs will be happy. In the previous example, you have plus times minus. Those two signs will not be happy. That will give you minus. But in this case, you are multiplying two signs that are the same. The two numbers, the two signs will be very happy. Minus times minus will always give you plus. Okay? So now drop down 7. Now, the final answer here is going to be, this is going to be 4p. Now look at this. Always start with the positive sign. This is minus 8 plus 7. I can also make it 7. Okay, you can read this way. 7 minus 8. So 7 minus 8 will give you minus 1. Okay, so that's the solution to this problem. So the final answer here is 4p raised to the power minus 1. Now let's try to look at the last one. Okay, you have 30 raised to the power minus 5 times let's say 2 raised to the power 8. Okay, you write out the numbers. That will be 30 times 2. You see that this is x raised to the power of minus 5. The multiplication sign will turn to what? Plus. Then you drop down 8. Can you see that? 30 times 2 will give you 60 because 2 times 0 is 0. 2 times 3 will give you 6. Okay? X. Now, start with the positive. This is going to be 8 minus 5. 8 minus 5 will give you 3. Right? 8 minus 5 will give you 3. So, the final answer here is 60x raised to the power 3. Okay, so now let's try to look at our assignment. So you are told to simplify the following expressions. So you have 5 questions in all. Apply the rules, the laws of indices for question 1, 2, 3 to 5. Okay. Now, if you have any problem in the course of this class, you try as well to pause the video, then endeavor to submit your assignment ahead of next class on Prodigy. I remain your humble tutor, Mr. Kamal. Thank you.